These videos are going to be for January 22nd, January 25th. We're looking at the trig sum and difference formulas. And then we'll also see how we can apply those formulas, how they're useful. Few things that we need to take note of before we start talking about this. I already gave the tangent sum and difference formula. A few things here. This is our Greek letter alpha. It's just a symbol. And beta. So those are our variables, if you will, in this, in our formulas, y, alpha, and beta. The only reason I can give you is that that's what's going to be on your formula sheet. So get used to it now, so it's not something funky on the formula sheet. You don't have to experience something new. We'll talk about the plus and minus here in a little bit, see how that applies as well. But here, if we have what we call a sign sum and difference, y sum and difference, well, we're adding and subtracting inside of sine. We're adding and subtracting inside of cosine. Adding or subtracting inside of tangent. So that's why they're called the sum and difference formulas. The sine sum and difference formula says if I have alpha plus or minus beta inside of sine, then that can become sine of alpha cosine beta plus or minus cosine alpha sine beta. And then the cosine sum and difference formula is cosine alpha cosine beta minus plus sine alpha sine beta. Now, a few things we need to know. They are different. The cosine and sine, like cosine is not sine alpha, cosine beta. It's different, right? Sine cosine, cosine sine, cosine cosine, sine sine. So be careful of that. That's one mistake I've seen so far. Another one I've seen is here. The notation here is correct. Here you have a plus and minus, which is something that you've seen maybe in the quadratic formula, and a plus and minus. Here you have, again, plus and minus. But over here, it changes to minus plus. And what this is telling us, really, these three formulas are really 6 formulas condensed into 3. And what I mean by that is, what this is actually telling us is, if we were to add here inside of sine, okay, I look at the signs and I think the addition is on top of the subtraction. So I stay with what's on top. When I go over here, addition is what's on top. So if I use addition here, I use addition here. But if I use subtraction out of the sign, subtraction is on bottom, it's below the addition. When I go over here, subtraction is also below the addition, so I would use a subtraction. Cosine, if I add here, again, addition is on top of the minus sign here. So when I go over here, what's on top, and that's the subtraction. So if I'm on top here, I go over here and I stay on top. Addition's on top, subtraction's on top. So if I'm adding here, I subtract here. If I subtract here, I would add here. And that's how we read this formula. Tangent, if I'm adding here, adding is on top, I would add here, but since subtraction is on top here, I would subtract there since it's on top. And we're very vague, very abstract right now. We will get see application, how this applies here in a little bit. And what we did after we looked at these formulas, talked about the notation, is we first verified it. So we have these formulas. We're going to verify that these formulas just work. We're not proving anything new. We're not showing any new values. We're just going to verify and make sure that these formulas do work. So we're going to do that for sine of 90. And the idea here is we only have one value here. In order to use the formula, we need to have something plus something or something minus something. So we talked about, can we add 2 numbers to get us 90? And what's going to be really helpful if those 2 numbers are on the unit circle, like in terms of degrees. And so what we talked about, a lot of students said, hey, 60 degrees plus 30 degrees, 60 plus 30 is 90. I have something plus something. Now we can utilize the formula to verify and just see how it works. We can also, if we refer to the unit circle, at 90 degrees, we already know what sine is. So we should, after we do all of our simplifying and everything, we should get that sine equals 1, because if I look at 90 degrees, the y-coordinate is 1, which means that the sine of 90 is 1. Now we use our formula. So here we have alpha plus or minus beta. Here I have 60 plus 30. So we can use this formula. We're going to use the addition part of the formula. Down here, if it helps you, we can relabel 60 as our alpha and 30 as our beta. And so now we plug those in here. Instead of sine of alpha, it would be sine of 60. Instead of cosine beta, it would be cosine 30. And that should be cosine of 30. Cosine alpha is sine beta, so cosine 60 sine of 30. And one of the biggest questions in starting to use these formulas is what's going to go in between these two terms here? Well, we use addition here. When I go inside of sine in our formula, addition is on top here. So because addition is on top here, when I go over here, addition is also on top, which means I would not put plus and minus. We choose one. Addition's on top, so we use addition. I'm going to slide this so we have room. And now you simplify. Now we can go to our unit circle. Sine of 60 from the unit circle, that would give us square root of 3 over 2. Cosine of 30 is also square root of 3 over 2. Cosine of 60 is 1/2. And sine of 30 is also 1/2. So if you were to simplify this, make sure you follow PEMDAS. We need to multiply these two things first before we can add. Multiplying fractions go straight across. So square root of 3 times the square root of 3 would just give us 3. 2 times 2, 4. 1 times 1 is 1. 2 times 2 is 4. Oh, gosh. Now you're adding fractions. You have a common denominator. So it would be 4 over 4, or just 1, which is what we wanted anyways. So again, like I said earlier, we're not proving any new results. We're not showing anything really crazy here. The idea behind what we just did is getting more practice with utilizing the formula, making sure we see how the formulas work, and then we can actually apply those formulas. I would encourage you to try cosine of 120 on your own. For example, if we want two numbers that fall in the unit circle, you could do, well, let me redo that. In class, we did two of them, one that's addition and subtraction. So you could do 90 plus 30. That would be your alpha and beta. And then you could also do cosine of, I don't know, 150 minus 30. Since that is also 120. And here you have your alpha and your beta. Now you can utilize the formula and simplify. Also, cosine of 120 is on the unit circle, and if you simplified correctly, utilize the formula correctly, you should get negative 1/2. Let you try that on your own. If you don't get negative 1/2 and can't figure out what your mistake is, please let me know. I can answer those questions. In the next video, we'll look at where these are actually useful. Why study these? Why actually look at these? But we'll look at that in the next video.